it logically. I'd like to help you in your struggle to be free. And I continue. There must be 50 ways to live your time. 1. By Kosen Handa. What is time? This is a question that has been on the minds of many philosophers since ancient times. Modern people are immersed in a socialized consciousness for most of their lives. They think of the concept of time as a sort of duration measured mainly by clocks. This image of clock time refers to the sense that there is a particular dimension called time separate from the three dimensions of space in the objective external world. In addition, we imagine that time flows linearly from the past to the future. From this linear concept of time, similar to space, we assume that time exists in the external world independent of our subjectivity, I, and space. This concept of time is very similar to Isaac Newton's idea of absolute space and absolute time. However, an event in physics at the beginning of the 20th century overturned this concept of time. It was the advent of Albert Einstein's theory of special relativity. According to the theory, space and time can no longer be considered separate modes of entities, but rather as a four-dimensional continuum called space-time, in which time and space are a coherent whole. It is often said that our space has four dimensions consisting of three dimensions of space and one dimension of time. However, to be precise, it is a four-dimensional space-time, and there is no independent dimension of time that exists separately from space. The characteristic of this concept of space-time is that time always exists as a set within space. Thus, if there is a spatial gap, there is also a temporal gap simultaneously. The space we inhabit cannot exist without time. The absolute measure in this four-dimensional space-time continuum is the speed of light. The speed of light is generally considered about 300,000 kilometers per second, but as I wrote in 2013 Serious Revolution, it is not something that fits in the concept of speed. Einstein himself clearly stated in his first thesis on the electrodynamics of objects in motion in 1905 that the speed of light will play the role of infinite speed in our physics in the future. In other words, in the physics system, 300,000 kilometers per second means infinite velocity. But what exactly did he mean by infinite velocity? Simply put, it means that the speed of light is not the same as what we generally regard as velocity. Due to the infinite nature of this light speed, any distance is supposed to be traveled instantly once the traveler reaches the light speed state. So, for example, if a rocket capable of traveling at light speed tried going to the Andromeda Galaxy, its crew would reach the galaxy in an instant, although it is said to be 2.5 million light-years away. That is because, as you know, time stops at the speed of light. But for the families of the crew left on Earth, 2.5 million years would have elapsed by the time the rocket reached the galaxy. Really? Well, it's a typical story that always appears in the general relativity manuals, but it sounds very strange, doesn't it? But the consequences of the relativity theory allow for such an incredible event. If we consider the expansion of space through this space-time concept, the world on the sphere that appears 2.5 million light-years away from the Earth is, In fact, 2.5 million years old. To recognize the expansion of macrospace, whether a star, nebula, or something else, we need objects. The information about the existence of that object is conveyed by light. Thus, the star we see on the Earth now is light emitted from a star 2.5 million years ago and arrived to us at present. Here, the concept of observing space through light is applied to our way of thinking. And we can see that such a premise for our idea about time and space implicitly depicts a picture of light traveling through space like an object in our mind. In our imaginary picture, a ray of light rushes through space at the speed of light. Suppose you place the flashlight on your left and the white screen on your right. When you turn the flashlight on, photons will be ejected from the bulb's filament and irradiated onto the screen several meters away. Then, with a precise measuring instrument incorporating an atomic clock, you'll be able to measure the time interval between the on of the switch and the arrival of the photons on the screen, and it measured the time 0.000 so many zeros 1 second, and so on. Well, something is strange with this idea. Here, the idea of distance, or in nosology's term, width, is dominantly reflected. In the system on the measured side of reality, which is a purely physical world, it may be sure that light travels at 300,000 kilometers per second between a given distance, i.e. the width, from here to there. But what is of our interest is the atemporal world of light itself, which is rushing along at the speed of light. What does it mean? Physics explains this timeless world in terms of a four-dimensional invariant distance expressed by the following equation. ds squared equals dx squared plus dy squared plus dz squared minus c squared dt squared, and ds squared equals 0. The equation shows that for light itself, any distance is meaningless. The theory of relativity was initially derived from the following two principles: the principle of relativity of motion and the principle of light speed invariance. In that context, the light speed invariance serves as an immovable, absolute system that compares the relative motions of two systems. However, many physicists do not seem to delve into the meaning of the light speed invariance as this immovable system, even though space-time exists based on the assumption of light speed invariance. Why is that? In nosology, the relationship between light speed and space-time evokes a vital significance. It is the boundary where the shift of our cognition from Naiman, the inside of a human being, to Gaiman, the outside of a human being, occurs, as I wrote in 2013 Serious Revolution. Since this is a very important point, I will mention it here again. Today's popular depiction of light moving through space-time at the speed of light is a fallacy. Instead, we should consider that there first existed the speed of light. All extended notions of time and space are mere derivatives of it. In nosology's expression, cognition of existence is essentially preceded by the outside of a human. Now, with all those in mind, let's examine the depiction of light moving through space. The light travels from here on point A to there on point B. Doctor, is that true? Yes. What makes you say that? I don't know. I just saw it. Oh, so you're saying that the light has traveled because you've seen it for real, as a fact? Yes, yes, because I, as an observer, verified it with my own equipment. So, if you, as an observer, did not exist, you would not be able to confirm that light travels from point A to point B at the speed of light, would you? Here again, you can see that the issue of objective and subjective lines, which I discussed in 2013, The Day God Sees God, is treated ambiguously. Newtonian physics was the physics of an uninhabited world where the existence of an observer was never an issue. The world exists with absolute space and absolute time in its background without any relation to I, the observer of the world. And the universe exists as a three-dimensional expanse of space with time ticking by every second, regardless of whether the observer exists or not. So, it was physics that dealt with the motion of objects unfolding in such a simple place. Philosophically speaking, this is the world of naive realism. However, with the advent of Einstein, the nuances of space and time have changed a little. I say a little because the conceptual framework for space-time has not gone beyond the realm of naive realism, although within physics it may be called a radical change. The reason is that although we call it physics, a conscious being called the observer has started being mixed in there. From this arises one simple intuitive deduction. The existence of an observer may be the key to the concept of four-dimensional spacetime. The observation of an event in relation to a description of when and where the event occurred. No event can be uncovered without a witness. Without an observer, space-time cannot exist. Then, in what way is the observer, the witness of space-time, involved in the event? And the most critical issue here is that this observing and measuring is also an event that is necessarily done by light.